How about this situation? First of all, the lines are not parallel. When the lines are not parallel, we know that there is an interaction. Is there a main effect for factor A, which is the type of TV program that students watch? Definitely, there is an overall difference between this and this. And if you look at this, here the mean for this is 83 and the mean for this one is 71. So there is a main effect for factor A, which is the type of TV program that students watch. How about factor B? Factor B is how much TV they watch. Is it large amount or is it small amount? As you see here, this is the average score for students who watch a little bit of TV, and this is the average score for students who watch a lot of TV. As you see, they're both at the same level in terms of high school GPA. So there is no difference, and the table also verifies that there is no difference between the two levels of factor B. So there is an interaction because the lines are not parallel. There is a main effect for factor A because this line is obviously higher than this line, and there is no main effect for factor B because this, which is the average of this and this, is at the same place or at the same level with this one, which is the average of educational and non-educational. So the overall conclusion of this chart is that the effectiveness of TV on a student GPA depends on how much they watch TV. If they watch a little bit, like just a few hours a week, it doesn't matter if they watch educational or non-educational. However, if they watch a large amount of TV, then depending on if they watch educational or non-educational, there is a significant difference in their GPA. An important thing here to note is that the main effects and the interaction are independent, which means we may have an interaction but no main effects, or we may have two main effects and no interaction. Now, these are more examples of possible outcomes. The first example shows a situation that there is a main effect for factor A, but there is no main effect for factor B. Again, why? Because this line is clearly above this line, so the main effect for factor A, and this dot is at the same level as this dot. That means that for factor B there is no main effect. In the second chart, there is a main effect for both factor in A and B. Why? Because this line is clearly above this line, and also this point is clearly above this point. So there are two main effects, but neither in case 1 or case 2 we don't have interaction because the lines are parallel. In the third one, there is an interaction between A and B. Why? Because the lines are crossing each other. But is there a main effect for factor A? No, because this line is not clearly above this line. And also there is no main effect for factor B because this dot is exactly at the same level as this dot. Finally, we have different types of mixed designs. So when we talk about factorial design, it doesn't mean that we definitely have an experimental design. We have 5 types of factorial design. First type is 2 between subject experiments. The other one is 2 within subject. And the third one is a situation when we have 1 between and 1 within subject factor. And we may have a factorial design that both factors are non-experimental. And finally, we have a situation where we have one experimental and one non-experimental factor. Let's take a look at some examples. So here is the research that the researchers wanted to know the effectiveness of pleasant and unpleasant words on memory, and they wanted to also include a second factor, which is the mood of the participants. In this example, one factor is non-experimental, which is the happy mood and the sad mood. In this example, one factor is a between factor and the other one is a within one. In other words, we have only two groups. We have two groups of participants. One group is in happy mood and the other one is in a sad mood. But for the happy mode, we have two situations. The first situation is they listen to pleasant words, and in the second one, they listen to unpleasant words. So this is an example of a combination of within and between subject design. Sometimes the variables are not experimental. They're not manipulated. We call this a quasi-independent variable. For example, if you are comparing male and female from two different departments of psychology and history, none of these factors is experimental. Factor A is gender and factor B is major. And finally, there is a situation when one variable or one factor is experimental and the other one is non-experimental. For example, we want to see if it makes a difference if the participants are speaking in front of a large audience or no audience. And at the same time, we want to control these experiments with students' self-esteem. So we have two groups of high self-esteem and low self-esteem, and we have two situations where the participants speak in front of no audience and the other one has a large audience. So one factor is pre-existing, which is high or low self-esteem, and the other one is manipulated, which is the number of audience. And there are situations that we may have three or more factors. In educational settings, this kind of research is hardly ever done. However, in science and especially medical science, we have a lot of this kind of experiments because there are so many factors that we want to include in our experiments. However, in an educational setting, for example, you may compare different teaching methods, but there are some evidence that may indicate that each of these teaching methods might have different effectiveness depending on the gender of the students and also the grade level. So the grade level and gender is going to be added into the equation as extra factors to investigate the effectiveness of these teaching methods.